Now we have equation 1 defining the current, equation 2 defining the current density, equation 3 for kappa, that is the specific conductance, equation 4 is for resistivity relationship with the specific conductance, and the fifth one is describing the electric field in terms of change in flux, that is the electric potential with respect to distance, that is shown here. According to equation 3, the current density is defined in terms of the electric field. So by comparing equation 3 and 5, we get equation number 6. So by comparing equation number 6 and equation 1 and 2, we get the value of current density that is equal to the 1 over A into change in or flow of charge with respect to time. Number is equation number 7. So by comparing equation 7 and equation 6, we get equation 7. So current flows in a conductive solution only when there is a gradient of electrical potential in the conductor. So such gradient can be produced by attaching the ends of the conductor to the terminals of the battery, as shown here. Equation 7 resembles the transport equations which are given by Fourier, Newton, and that fit also to the Fick's law. So here we can write the generalized form of equation, that is the 1 over A is the cross-sectional area. So this one is equation 8. So here A is cross-sectional area, W is any physical quantity that is physical quantity being transported so it can be Q in thermal conduction. So here Py can be for the viscous flow, Ng for diffusion, and Q is for electrical conduction. So this W constant is the any physical quantity that is being transported. L is a constant which can be K for thermal conduction, eta for viscosity or viscous flow, diffusion coefficient for diffusion, and kappa for electrical conduction. whereas dB over dx is a gradient of physical quantity, which is temperature for the thermal conduction, velocity in y direction for the viscous flow or for the determination of viscosity. Ci is the concentration of ionic species, whereas the potential or electrical potential for the electrical conduction. So this quantity or the parameter is known as flux, or which is proportional